Hello everyone, welcome to our lesson 1.6, a library of parent functions. The first parent function we're going to talk about are linear functions. All linear functions are representations of lines. That's it. And we can write them when we're given 2 points or when we're given a single point and a slope. As a reminder, we can write linear functions in the form f of x is equal to mx plus b. This takes us into example 1. We're going to write the linear function f for which f of 1 is equal to 3 and f of 4 is equal to 0. As a reminder, this is just function notation for 2 different points. We have 1 point, 1, 3, and another point, 4, 0. And we can find the slope from that. Remember, the slope is m equals y2 minus y1 over x2 minus x1. And it doesn't matter which point you pick to be your 2 and which point you pick to be your 1. We can easily find the slope here. So let's just pick the first point, the 1, 3, to be our x1 and y1, and the second point can be our x2, y2. So in this case, our slope is going to be 0 minus 3 over 4 minus 1. And 0 minus 3, we know is negative 3. And 4 minus 1 is 3, which means our slope is going to be negative 1. I'm going to write that over here on the side because I'm going to erase what I have so I can continue my work. So there's then a couple different methods we can use to solve this, and I want to show you both of them. The first one, we can utilize the point-slope form of an equation for a line. And as a reminder from Algebra 1, the point-slope form of the equation of a line is y minus y1 is equal to m times x minus x1. We've got our m, and we can take either of the points we're given and plug them in for y1 and x1. So let's just use the first one again. So in this case, f of 1 is 3. That's going to be our y1. x1 will be our 1. So let's plug those in. We've got y minus 3 is equal to m we found to be negative 1 times x minus 1. And let's put this in f of x equals mx plus b form. So what we need to do is distribute our negative 1 to x minus 1. So our next line of work will be y minus 3 is equal to negative x plus 1. And to solve this for y, we are going to have to add 3 to both sides. And we're going to end up with y equals negative x plus 4. And in function notation, we just replace the y with f of x. So we end up with f of x equals negative x plus 4. That is one method. I'm going to erase what I have here and show you another method for doing this. This method still is going to utilize m equals negative 1, and we're going to use one of the points, but instead of using the point slope form, we're going to go straight into using slope-intercept form, the f of x equals mx plus b. And again, let's just use the first point, f of 1 equals 3. So we're going to replace f of x with f of 1, which was 3. We're going to replace m with negative 1, and we're going to replace x with our x value. And x, when f of 1 is equal to 3, x equals 1. We don't know b in this case, so we're going to solve this for b. And in doing this, we know 1 times negative 1 makes negative 1. So we've got 3 is equal to negative 1 plus b. And by adding 1 to both sides, we can figure out that 4 is equal to b. And then we can just plug that back into our f of x equals mx plus b with all the information we know. So from this, we can conclude that our function is f of x equals negative 1 times x is just negative x plus 4. The same function we got using the other method. You can choose which method you like best when solving this. Continuing on with linear functions, there are two special cases, or two special types of linear functions. Our first special case is a constant function. All that means is the function is written in the form f of x is equal to c, and c is any number. The other case, case 2, is the identity function. All that means is we're going to have f of x is equal to x. For any value of x, y is going to be the same thing. That's all that means. We also have the squaring function, which is given by the function f of x equals x squared. As a reminder, f of x equals x squared is a quadratic function, which means that if we were to graph it, it would make a parabola, and parabolas are u-shaped. So that is one characteristic of f of x equals x squared. We also want to talk about the domain. And as a reminder from the last few lessons, the domain of a function is just the x values that we can put in to make this function work. And in this case, the domain of the function is the set of all real numbers. So there are absolutely no real numbers that we cannot use. The range is the other thing we're going to talk about. And the range of a function, as a reminder, is all the y values that are found when we put x into the function. So in this case, the range of the function is the set of all non-negative numbers. Because any value we plug into x, for x, we will square it, and a negative number squared is positive. Another thing that we talked about in our last lesson is odd or even, and from that, we can determine that this function is an even function. This graph, if we were to graph f of x equals x squared, has an intercept at the point 0, 0. Another characteristic of this function is that the graph is decreasing from negative infinity to 0 and increasing from 0 to infinity. which in the last lesson we wrote with parentheses from negative infinity to 0, we are decreasing, and we are increasing from 0 to infinity. Another characteristic is that the graph is symmetric with respect to the y-axis. And finally, the graph has a relative minimum at the point 0, 0. So a really rough sketch of what this graph would look like is as follows. We create our x and our y-axis. And we would have a parabola with a relative minimum at 0, 0. It is decreasing from negative infinity to 0, and it is increasing from 0 to infinity. That relative minimum is also a y-intercept, and since it turns one time, our function is even. Another parent function we should talk about is the cubic function. Which is written in the form f of x is equal to x cubed, or to the power of 3. The characteristics of the cubic function are the domain of the function is the set of all real numbers, and that the range of the function is the set also of all real numbers. When graphed, or even from just looking at f of x equals x cubed, we can tell that the function is odd. Most of our parent functions will have this in common. The graph has an intercept at the point 0, 0. The graph is increasing from negative infinity to infinity. And the graph is symmetric with respect to the origin. A rough sketch of the cubic function after we put in our x and our y-axis will look roughly like this, where we have our intercept at 0, 0, and we are increasing all the way from negative infinity to positive infinity. We also have the square root function. The square root function is given as f of x is equal to the square root of x. Some characteristics of the square root function. In this case, the domain of the function is the set of all non-negative real numbers. And that's because we don't know the square root of negative numbers to be real. Those are imaginary. The range of the function is the set of all non-negative real numbers, because any non-negative x value we put in for x is going to give us a non-negative value for f of x. Another characteristic is that the graph has an intercept at the origin at 0, 0. And finally, the graph is increasing from 0 to infinity. If we were to sketch the square root function after putting in our x and y axis, it would roughly look like this, where we have an intercept at 0, 0, and the graph is increasing from 0 to infinity, where all non-negative or all positive x values are in the domain, and all positive y values are in the range. The last function I'm going to talk about in this video is the reciprocal function. The reciprocal function is sometimes also called an inverse function. It's given by f of x is equal to 1 over x. Some characteristics of this reciprocal function is the domain really includes almost all x values. So almost all real numbers except x cannot be 0. The range is also very similar. So it includes all real numbers except y cannot be 0. This function, if we're talking about odd versus even functions, the function is odd. This graph has no intercepts. The graph here is decreasing from negative infinity to 0 and from 0 to infinity. And the graph is symmetric with respect to the origin. If we were to create a rough sketch of this reciprocal function, first putting in our x and our y axis, it would roughly look like this. There are no intercepts. It is decreasing from negative infinity to 0, as well as decreasing from 0 to infinity. That's going to conclude this part of our lesson on 1.6. Stay tuned for part 2.